Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. Now make sure to stick to the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 7 to the power of x is equal to 70. So I want to find the value of x here. So for my solution, first start with 7 to the power of x is equal to 70. Now I'm going to take the log on both sides. So now I have log 7 to the power of x is equal to log 70. Now an important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front. So this would equal b times log a. So in the case of log 7 to the power of x, I can move x to the front. So that's going to equal x times log 7, which is equal to log 70. Now log 70, that's the same thing as log 7 times 10. And now if I have something in the form log a times b, this is simply equal to log a plus log b. So log 7 times 10, that's going to equal log 7 plus log 10. Now I'm going to go ahead and divide both sides by log 7. So then these two are going to cancel out, and now I'm going to be left with x is equal to log 7 plus log 10 over log 7. Now this is the same thing as log 7 over log 7 plus log 10 over log 7. So now log 7 and log 7, these two cancel out, so now I'm left with x is equal to 1 plus log 10 over log 7. Now log 10, that's simply equal to 1. So now I have x is equal to 1 plus 1 over log 7. Now what we're going to do is we're going to find the value of log 7. So log 7, this is equal to 0.845. So now I have x is equal to 1 plus 1 over 0.845. So now 1 over log 7, or 0.845, the value of that's going to be approximately 1.18329. So now if I add that with 1, I get 2.8329. So this is my answer. Alright, so I have x to the power of x to the power of 5 is equal to 100. Now the first thing I'm going to do is I'm going to take the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. And a to the power of m times n, m and n are interchangeable, meaning this could also equal a to the power of n times m. And if a to the power of m times n is equal to a to the power of m to the power of n, then this means that a to the power of n times m, this is equal to a to the power of n to the power of m. So in simpler terms, a to the power of m to the power of n is equal to a to the power of n to the power of m. So in this case, we could think of x to the power of 5 as m and 5 as n. So if I switch those two places, I get x to the power of 5 to the power of x to the power of 5 is equal to 100 to the power of 5. Now 100 I can rewrite as 10 to the power of 2. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 2 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 10 to the power of 2 to the power of 5, that's going to equal 10 to the power of 2 times 5, which is the same thing as 10 to the power of 10. Now, if I have something in the form a to the power of a is equal to b to the power of b, this means that a is equal to b. So in this case, x to the power of 5 is equal to 10. Now I'm going to take the fifth root on both sides. So these two cancel out, and now I'm left with x is equal to fifth root of 10. So this is my answer. Alright, so I have x to the power of x is equal to x to the power of 2. So now the first thing I'm going to do is I'm going to divide both sides by x to the power of 2. So now these two are going to cancel out, and now I'm going to be left with x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, x to the power of x over x to the power of 2, that's going to equal x to the power of x minus 2, which is equal to 1. Now I'm going to take the natural log, or ln, on both sides. So now I have ln x to the power of x minus 2 is equal to ln 1. Now, if I have something in the form ln a to the power of b, I can actually move this exponent b to the front. So this is going to equal b times ln a. So in this case, for ln x to the power of x minus 2, I can move x minus 2 to the front. So this would equal x minus 2 times ln x is equal to ln 1. So now, ln 1, this is actually equal to 0. So now I have x minus 2 times ln x is equal to 0. So now this is going to give me two equations. I have x minus 2 is equal to 0, and I also have ln x is equal to 0. So for x minus 2 equals 0, all I have to do is simply add 2 on both sides, and I get x is equal to 0 plus 2, which is 2. So this is one solution. Now for ln x is equal to 0, I'm going to e to the power of ln x is equal to e to the power of 0. Now e to the power of ln x, the e and ln are going to cancel out, so now I'm left with x is equal to e to the power of 0, which is 1. So my two solutions are x equals 2 and x equals 1. So now to check, my equation is x to the power of x is equal to x to the power of 2. So my first solution is x equals 2, so now I have 2 to the power of 2 is equal to 2 to the power of 2. 2 to the power of 2 is 4, so I have 4 is equal to 4. This is right. Now my second solution is 1. So now I have 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is also 1. So these two are right as well. So both my solutions are right.
Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So our equation here is 6 to the power of x equals 9. So we want to find our value of x here. So our first step is to take the log of both sides, or to multiply by log on both sides. So this gets us to log times 6 to the power of x equals log times 9. And an important property of logarithms is known as the power property. And this states that log, let's say if we have log a to the power of b. Well, this is the same thing as b times log a. So as you can see, what we did was we took our exponent here and we moved it right in front of the log. And this is one of the important properties of logarithms. And you can actually do this with logarithms. So right here, we have log 6 to the power of x. So how would we simplify this using our power property? Well, as I just told you, we're going to take our exponent, which in this case is x, and we're going to move it right in front of our log. So this changes into x times log 6 equals log 9. All right, so now we've gone this far, and our only job now is we want to isolate our x. So to do that, we're going to have to divide by log 6 on both sides to get rid of log 6 on this side. So if we divide by log 6 on both sides, well, these two cancel out, so we're left with x equals log 9 over log 6. And this is our exact answer. However, we still have to write this as an approximated answer. And to do that, we're going to use a calculator. So if I plug this in my calculator, x is approximately 2.23. And there's no way you can actually do this using paper and pencil. You really have to use a calculator to do this. So our exact answer is x equals log 9 over log 6, and our approximate answer is x is approximately 2.23.